Imagine you flip a switch and a tiny gravity well blooms in midair. No spinning wheels. No magnets, just a pocket of artificial gravity bending space itself. You slip a droplet of pure water into that zone. At first it hovers like a perfect glass marble, surface tension, holding it smooth and spherical. And you dial up the field, the bottom of the sphere flattens into a crisp meniscus, exactly like water on a dish. Except the dish is invisible. As you tweak the gradient, making gravity stronger at the center and weaker near the edges, the droplet reshapes into a pancake, then into a delicate ring. Surface tension wrestles with the artificial pull, and tiny capillary waves race across its surface at kilohertz speed. You catch those ripples with a laser vibrometer, mapping their frequencies. They shift predictably as you adjust the local G, a pure dance of fluid dynamics and gravitational physics. Next, you impose a radial grade. Strong pull at the core, gentle slope outward. The water forms a volcanic crater shape, steep walls near the center, broad, shallow slopes at the rim. In this imaginary lab, you can observe hydrostatic pressure falling off not with depth, but with radial distance. Your pressure probes record a curious reversal. Lowest pressure zones
At the crater's lip?
highest at the steep inner wall. The water seems to defy everyday intuition, yet obeys the same Navier-Stokes equations we know from Earth. Then comes the showstopper. You oscillate the field at low frequency, syncing it to the natural resonance of the droplet. It breaks symmetry, and the ring turns into a rotating torus of water, spinning on its own. Centripetal effects and your art gravity field combine to stabilize a floating vortex, an island of swirling fluid held aloft purely by tunable space-time curvature. You trace the vortex core with fluorescent dye. It glows like a cosmic hurricane. By monitoring tiny tracer particles, you watch how the local gravitational potential sculpts fluid streams. You even introduce heat. A microheater at the gravity well's rim sends plumes of steam spiraling outward, carving helical cloud patterns inside the drop. You realize this is a microcosm of atmospheric vortices, but on a millimeter scale, inside an invisible gravity dome. In the end, you shut off the field. The water droplet collapses into a free-floating blob, then drifts away under uniform Earth gravity. Yet you've uncovered deep links between variable surface tension and fluid resonance. Though we can't build a gravity bubble generator today, this thought experiment shows how bending spacetime locally would let us explore new regimes of microfluidics, model planetary ring dynamics in a blink, and perhaps even craft floating fluid architectures for future space habitats. It's pure imagination, but firmly rooted in Newton's laws, Einstein's insight, and the timeless beauty of water.